Hello, my name is Peter Stanton and I own a company called Edge Precision Metal Products, and also I have a YouTube channel called Edge Precision, and I do a lot of machine work on that YouTube channel showing these jobs that I do on the machine tools, and occasionally I show a custom tool that I've ground, and I do quite a bit of this custom tool grinding for Centerline here and myself and some customers here in Houston. And I also post pictures of a lot of those tools on Instagram, and my Instagram name is Peter L. Stanton, in case you don't know that, because I've had that question quite often in the comments. And also in the comments I've had people ask about this tool grinding and want to know a little bit more about it, so I thought I'd make this video about grinding this end mill. So this is just going to be a video about grinding pretty much a standard bull-nosed end mill, just as an example to show you what's involved with the computer part of it, and then I'll run the end mill on the machine. You really can't see that because of the flow of the coolant is really it blocks your view. You can't see anything. So I'll run the tool, grind it, and then I'll show you the machine running over it again dry without the coolant, so you can see what's happening. So let's get to the computer first here, and then we'll get to the grinding. So this is the Numroto software. The actual machine, this is the machine's page that the machine as you're running the machine, you would be looking at this page here. And the software you program to cut or grind, I should say, tools is this. It's called Numroto. This isn't a very new version of it. This machine is quite old, but it still does a lot of things, this version. So if you select this, these are the options you have in here. I guess there's many more modules you can have, but these are the 4 that I have for grinding tools. So this is just standard end mills. This would be a form tool, which would be almost any shape you want, and step drills and burrs. I have never actually ground a carbide burr, so I'm not really sure about this one, but I've used these other 3 quite a bit. So I thought we'd demonstrate just a standard type of end mill. So if you select this selection, and then we can say new, we're going to make these options you can do on the end mill. These are like standard cycles, I guess you call them, but you can adjust the geometry in many different ways for these specific cycles, I guess you would say. So let's just select we're going to do let's select a corner radius end mill, because that would be a little bit more difficult to grind, if you had like a manual tool and cutter grinder, just to demonstrate what this can do. So we'll say we're going to manufacture. You could either resharpen or manufacture. So we're going to select manufacturing here. We're going to select size. Let's just say 1 inch for the cut length, and we'll put about a 60 thousandths tip radius on here. You can either select the diameter, as you can see here, of where the radius ends, or you can select the cylinder's diameter. I'm going to select 0.4375 because I happen to have some blanks left, a lot of extra blanks of that size. So if we go ahead and grind this, I have the material to do it with. Core diameter, I usually set this roughly half of the OD just to start with, so 0.4375 divided by 2 would be 0.218. That's a good starting point. You can adjust any of this when you get further along. Taper, there is no taper. We're going to make a straight end mill, and this is the dish angle of the end of the tool. Typically an end mill will always have a dish angle unless you want one flat for a special purpose, or you can actually put a negative number in here and actually make a point sticking outward. Like if I put minus 45, see how over here on the little thing it kind of gives you an idea of what the tool's going to look like. See how it looks? It has a point, so you have a tapered tool with a radius in this case, but you can't go any See, if I try to go minus 46 degrees, for instance, it doesn't let me. See how it's put it in red right here? So, or something of that nature. So you can only go plus or minus 45 degrees with this standard grinding cycle. So what do we have, 1 degree here as far as that went? That would be taper this direction, which is what most standard end mills have. They have 1 to 1.5 degrees on that. It's actually angled upwards so that the tips of the flutes cut here instead of the center. So we go next for the next thing, and here we can select the number of flutes. We'll just select 4 flutes with 2 center cutting flutes here. So that would be the number of flutes. You could actually have an irregular pitch if you selected over here, and then you would have selections of the angles you want the teeth to be at. So that would be a variable pitch end mill. We're going to go back here and just make it a standard end mill. And then you have the normal reliefs, which are just like you're probably used to seeing, which are just flat reliefs. Or you can have radial reliefs, which are actually curved, or a radius kind of a thing. This can be good for certain things. If you're machining certain materials, it makes the cutting edge quite a bit stronger right at the cutting edge if you do this. For this purpose, we're just going to go with the normal relief angles like a standard end mill's ground to. And this is the helix here of the angle. You can, if I change this, you can see how the picture over here kind of changed a little bit. So that's a shallower helix. So 30 degrees is just about a standard thing. Now here again, you can put a constant angle, constant lead, constant angle, straight flutes, variable flutes, and differential helix. Okay, so you can do all of these things here, but to keep it simple for right now, we're just going to leave a constant lead. But you can see that you could actually put like a variable or differential helix and an uneven spacing, which a lot of modern end mills have nowadays to reduce chatter or vibration in the tool. We're going to just stick with constant lead right now on this particular demonstration. And the material's carbide, and this just defines the blank, all of this information here. You don't really have to do anything with this if you don't want to, although the diameters here will have an influence maybe on the approaches of the grinding wheels when it figures out how to approach them. But it's set at the full blank diameter because that's what I'm making a tool that size here. If your tool was different diameter at the cutting edges than your blank, you might want to adjust these dimensions. Okay, so then we just go next here, and this is going to be our setup on the machine. So if we want to grind these 1-inch flutes, we need a little clearance on the collet. So let's just say we stick this out about 1.75 inches from the face of the collet, and I happen to know on my machine this number is always 5.8 inches to the end of the collet, and the 7/16 collet is probably about 600 thousandths in diameter on the tip. Okay, this refers to just whatever the blank definition is. It may not have anything to do with reality unless you define the blank on the previous page, and then this would be accurate. I didn't really do that in this case. This is going to be the start angle of where it's going to start grinding the flutes. You could adjust this if you wanted to for some reason, and this number here is where the machine is going to probe if you're going to probe the flute spacing. But if you're starting from a solid blank, you don't even do that. So we'll just leave that alone for right now. So we'll say finished. Okay, and these are the cycles that it came up with. You got to flute the tool, flute, gash the end of the tool, a relief angle 1 and 2 and 3. Now I normally don't even put a third relief on an end mill, so I just leave that out. I'm just going to delete that one. You can always add it later if you feel like you need to. But now we have to set up some grinding wheels. And normally a grinding wheel pack has 3 grinding wheels on it to grind a standard end mill. So this one that I've defined is what I call a Naxo end mill. If I tell it to show the package over here, you can see this little icon of the wheel pack. So it has 3 grinding wheels on it. It has this is going to be the fluting wheel, which is what I've selected for the fluting operation here. And I'm going to say okay, but this wheel here would be the gashing wheel, and this wheel, the cup wheel, typically is how you grind your clearance angles on the cutting edges. So we're going to select that wheel for the flute, and we're going to select this wheel, like I said before, for the gash of the end mill, and then we're going to select this cup wheel. You see, it already knows what grinding wheel pack I'm using, so it's selecting the appropriate wheels actually almost automatically for this particular tool. And then we're gonna turn the coolant on all positions for all these wheels. Okay. Okay, and okay. Now we can immediately do a simulation of this here, the simulation. Let me see if I can reduce this down a little bit. And we can watch the simulation. This is how easy it is to actually grind an end mill. But there's going to be some adjustments we're going to want to make here before we actually would grind this tool, but it gets it pretty darn close just right out of the box, so to speak. Usually I put some, if you can see this over here, some tapering off here, and I change these relief angles a little bit usually on some of this. Down here you can kind of see the load that the various wheels are going to be under. See this, if I double click here, it's going to show me my fluting wheel in there grinding the flute, and you see the load is quite a bit higher than any of the other tools. See, this will be the gashing, the first pass of the gashing tool or wheel, which gashes the end of the end mill. And so I usually, it depends on what you're trying to do and how fast you're trying to grind the tool, I guess you'd say, but I usually don't like to put so much load on the grinding wheel, because it's grinding, it's pretty much creep grinding this whole flute in one pass. So I like to usually slow this feed rate down a little bit, and I like to reduce this primary clearance width a little bit narrower, usually on the tools I grind. So let's minimize this. We'll go back to the cycle here, and let's reduce this feed rate down to about 2 inches on the fluting. The gashing feed rate's probably alright. That I usually don't have to mess with that too much. On this, the feed rate for the cylinder of this, I usually slow this down, and the corner radius I usually slow down, because if you go too fast around this corner radius on a bullnosed end mill like this, is swinging that grinding wheel around, and it can leave marks in the radius. So I usually slow that down there, and as well as on the finish, this would be the primary clearance, and this would be the tip. I guess I'm going to slow those feeds down as well. It'll grind them this fast, but it usually does a better job. I mean, it leaves a nicer finish on the grind. You know, these production end mills, if you look at them, the ones you buy, and if you magnify that cutting edge, it'll look like almost like a sawtooth, because they're trying to make money and grind these things as fast as they can. This has a simulation for time, and you can see here it says it'll take a little over 15 minutes to grind this tool at those feed rates that I've given, which is probably too long for a production shop. You know, they want to grind it faster than that. But I don't worry so much about that because I don't do production grinding for tools. So that's usually that's all that's required actually to grind an end mill here. Oh, forgot one thing. I'm gonna move this primary clearance down after the secondary clearance in this case, and I'm gonna reduce the size of this land to 15 thousandths. As you can see here, you have a lot of control over all of these angles of the clearance angles and where it starts in the center of the end mill. Right now it's going to put an 8-degree all the way down. But if I wanted more clearance in the center or out at the corner radius or at the cylinder part of the tool, and right now it's doing a 5-axis move. You can select 4 or 5-axis here as well. You have some control over the centering parameters here depending on what you want to do for the center cutting flutes, as well as the 2 flutes in this case that aren't cutting to center. So you have ultimate control over any of this if you wanted to. I'm going to increase the flute length back a couple of 100 thousandths as well beyond the cutting edges. And I also said I was going to put an angle on the end of this thing. I like to do this just because and usually about 30-degree angle, just because it leaves you don't have this sharp ridge right at the you know, at where the grinding stops, where the flutes are. But if you look at most production-made end mills, they don't even worry about this. So let's re-simulate that, and we'll look at the loads on the grinding wheels as well as the rest of it. Now I happen to have hit the flute depth just about perfect, it looks like, on this tool. But if you needed to increase the flute depth, you could do that. Now you see what changed here. I increased the length of this flute going beyond the cutting, you know, the cutting edges. I kind of like to have it like that when I grind tools, just to have a little more clearance for shavings if you're taking a cut all the way to the end of this cut length. And you notice the primary land is narrower here as well. It might pay to do a little explanation of the features of an end mill here. Let's look at just the tool, in case there's somebody that doesn't know these terms. See the green area here at the tip of the tool? That's called the gash of an end mill. That's where you cut this for clearance if you're plunging. So shavings coming off of this center cutting flute can come out and allow the tool to cut, as well as it gives it a cutting edge down the face of the tool. If you just fluted it, this flute would run out, but you wouldn't really have any cutting edges here unless you did this gashing operation, they call it. And the gash has many parameters that, if we look at the cycle, that you can change. You can change the angle of it. You can change the angle of your grinding wheel when it grinds it. You can change this angle of the back angle of it. You can change the centering data for both sets of flutes. This usually comes out pretty good just right out of the box on these standard grinds, but you can change all of this if necessary. And then you can change the way it widens the flutes, as far as the center cutting ones as well as the ones that aren't cutting to center. You can do in this case it's doing a walk travel, where it's traveling down this 45-degree angle for 43 thousandths, and it doesn't have a second part to it. But you can do all of these kind of things. You can do, you know, do not widen. Walk travel is what it's doing. Opening, which just tips the grinding wheel. Walk travel and opening, which does both of those things. Or you can do a radius down at the bottom. It kind of does it doesn't I guess it doesn't show a picture of this, and a radius and an opening. Well, this is what the radius thing would look like here. But the radius would be just the radius part, but this is a radius, and then it's feeding sideways to open this up, which that sounds like that could be good. I usually don't bother. I just use this walk travel thing. This is pretty much a standard grind. I've done these others on form tools for various reasons, but just for this demonstration, we're just going to use that simple one. With the fluting operation, you can change these parameters. You can change this rake angle of the inside of the cutting flute, and you can change the depth of the flute, the measuring depth here. That has a lot more to do with probing it if you're having to probe it for some reason. But actually, it is the depth of the cutting rake edge, I guess you would call it. And then you have the angle of your wheel. You can adjust that if you wanted to, and this would be, I already modified the length behind. The length in front you might modify if you were doing something special, like if you had put a negative angle on the front of this tool and your grinding wheel was starting out here with stock, it might be hitting it or something and causing the wheel to overload or something. Up here in the geometry, you can change various things too, as far as the core diameter, like we initially set up, and the number of teeth and the blank size and everything. This we normally set up while you are defining the tool, but then you can go back if you needed to and change any one of these. One thing I usually add too, insert here, and see, you can insert all of these cycles into the standard cycle, which here's the body clearance, which is sometimes you grind this, particularly on two flute tools where you only have two flutes and you got to grind this clearance in between the flutes. You cut off flat. This is the one I'm going to add. Let's just add this real fast, and I'm going to use this grinding wheel to do it here. Because I added a new cycle, I got to enable the coolant lines. And what this is going to do, I'm going to select just to grind right down the tool, and I'm going to change these a little bit because I'm not doing every flute. I'm just going to grind the face down and leave we'll say 0.05 stock on the face. I do this just because if the blank's slightly out of square or something, this is usually a good thing to do. So if I go back to my simulation and I just say it's a cylindrical blank and on the OD I'm going to leave 0 stock, and I'm going to tell it there's 30 thousandths on the face. So if we go back to our simulation, it says the blank has changed. Yeah, we're going to say it's okay. And I'm just gonna do one operation at a time. See that? It just ground the end of the blank flat. That's usually a good idea because I've ground a whole end mill and then I looked at the end of this thing and I said, oh man, it didn't clean up on the tip of it. So I usually do that just to be safe. Then the next operation is the fluting operation, like that. And then gashing here. That's the gash. Otherwise you wouldn't have cutting edges on the face of the tip of the end mill unless you'd gashed it. And then these are the clearance cuts. So that's the secondary clearance. And then this is the primary clearance, or the cutting edge, if you will. Now if we look carefully at this, you'll notice that there's the angles. This gets kind of pixelated when you zoom in on it a lot, but there's the angles of the that I put on, if you remember. And as I showed you earlier, you saw those parameters you could do with this gash. And see, actually, you see how this isn't completely cleaning up that where the grinding wheel's going down. I could either move the center of this secondary clearance angle down further, but in reality I'd rather just widen this gash a little bit here to take care of that, because you get down too close, you're going to be hitting this other flute with the grinding wheel. So this is the non-cutting gash width. So we're going to go back here and we're going to go to our gash parameters, and the centering, the widening is what we want to do, and we want to do it on the second set of flutes, which are the non-center cutting. And we're going to just change this walk length to I'm going to put 40 thousandths here. Let's see what that looks like. That was not quite doubling it. So let's re-simulate this and see if that took care of that little bump that's left on that tip clearance angle. You see how that grinding wheel would be getting awfully close to the flute if I moved it too close over there, because of the way you grind this bullnose end mill. So widening that, see, it pretty much took care of that area that didn't clean up, I guess you'd say. Yeah, here's the actual grinding operation of the end mill. As I said, I'm rerunning it so that you could see what the motion is without the coolant. Here's the fluting wheel cutting the flutes. I'm not going to show every single pass of every wheel, but I'm just going to show enough so you can get the idea of the motion of the machine here. So this is looking at it from the inside the machine, of course. And this view over here is from the front, the door side of the machine. And then we come up with the gashing wheel, which is the one closest to the spindle face here, with the steep angle, the 45-degree angle there. That's going to gash out the tip of the end mill. So there's all the 4 gashes. And you come around and grind the clearance angles for the cutting edges here. You can see the motion, the full 5-axis motion. When you look at the control running this, you only see one G code running. You know, it's like this G code, and that's it. There's no like code going by that you see, so it's all done in a macro of some sort, or a special G code. I don't know how they figure out this path, but it's got to be some pretty fancy calculations to do that, if you can see that motion there. So that just gives you the highlights of the grinding, really. And then we can get some close-up shots of the finished tool here. So it looks pretty much like the picture in the simulation on the control. So if this is the first time you ever watched one of my videos, please subscribe. And to everybody else, thanks for watching.